Hi everyone, and welcome to this talk on distribution-free goodness of fit test for the Pareto distribution based on a characterization. And this talk is joint work with James Allison, Bojana Milicevic, Marko Obradovic, and I will be the presenter today, Marius Smuts from the Department of Statistics, Northwest University, Potchefstroom, South Africa. So to start off this talk, let x1 up until xn be a sequence of independent and identically distributed continuous realization of a random variable x with some unknown distribution function, and let's denote that distribution function by f. If x follows a Pareto type 1 distribution with density function gx, it will be denoted by x is Pareto distributed with parameter alpha. Now the composite goodness of fit hypothesis to be tested is that the distribution of x is Pareto for some alpha greater than 0 against general alternatives. And this hypothesis we will denote by 1. To test this hypothesis in 1, we propose 3 new classes of test based on the following characterization of the Pareto distribution. So let x1 up until xn be IID non-negative absolute continuous random variables, x to the power of 1 over m and the minimum of x1 up until xm have the same distribution if and only if x is Pareto distributed for all integers m larger than or equal to 2 and less than or equal to n. Now this follows directly from the Peary-Rubin characterization of exponentiality and the relationship between the exponential and the Pareto distribution. Now the 3 classes of tests depending on m is based on the difference between the V empirical distribution of x to the power of 1 over m and the minimum of x1 up until xm. Now this will be denoted by delta nm. So the test statistics are then an integral type denoted by inm, a Kolmogorov-Smirnov type, which is just the supremum of delta nm, and that is denoted by knm, and then the last one is a Kramer von Mises type test statistic denoted by capital MNM, and in all these cases fnx just denotes the usual empirical distribution function. Now it's important to note that it can easily be shown that all these tests proposed here, all 3 tests, are free of the shape parameter alpha. Next, we will consider the asymptotic properties of the new tests, but due to time constraints, we will only consider the asymptotic null distribution of the Kramer von Mises type statistic denoted by MNM. Now, after integration and simplification, the test statistic has this form given here by MNM, which is a V statistic of order 2m plus 1. Now let phi x1 up until x2m plus 1 be its symmetricized kernel. The first projection of phi is equal to 0, while the second projection, little phi, is mst, is given or is analytically obtainable but too long to display. Now a complete expression can be found in the paper under discussion here. Since the kernel phi m is bounded and degenerate, it follows from the theorem for the asymptotic distribution of U statistics with degenerate kernels and the theorem connecting these U and the V statistics that under the null hypothesis that m n m converges in distribution to the infinite sum given there on the right hand side, where delta k are the eigenvalues of the integral operator script mm defined for any function of this integral operator, and zk or IID Gaussian random variables. We also derived and calculated the local Bahadur efficiencies for the three new tests I, K, and M, as well for the two integral tests Ti(n) and T1n and T2n proposed by Obradovic 2015, which are based on a characterization property of the Pareto distribution. Now let script G be a family of alternative distribution functions such that Gx0 is Pareto. So we will calculate the Bahadur efficiencies for the following alternative from the class script G. And the ones we considered are the log-Weibull distribution, log gamma, inverse beta, Pareto distribution, mixture of Pareto distributions, and the Benini distribution. So next we will consider the table containing a summary of the local Bahadur efficiencies of the newly proposed tests, and from this table it is clear that the integral type test INM has superior local Bahadur efficiencies for the alternative distributions, and that the new Kolmogorov-Smirnov type test are the least efficient of the test under consideration. We have also found that values of either m equal to 2 or 3 leads to the highest efficiencies in general for the newly proposed test. To conclude this talk, we will be showing some of the estimated powers for various tests against some of the alternatives in script G. Now here, omega squared n and ksn is the traditional Kramer von Mises and Kolmogorov-Smirnov tests respectively. Now this table shows us the estimated powers for the various tests based on 10,000 Monte Carlo samples for sample size equal to 20. Now what's interesting to note from this table, just the side note, is that the highest powers for each alternative is highlighted or made in bold. So what's interesting to note from this table is that the new Kolmogorov-Smirnov test outperforms the integral type test for these alternatives, where actually the opposite happened when we considered the Bahadur efficiencies. Thank you very much.